Yesterday you learned how to solve multi-step inequalities. Today we will learn how to solve compound inequalities. Follow through with the examples, just like yesterday. Um, okay, this paper needs to be completed by the end of the hour and turned in. All right, so let's start with the notes. Okay, our goal, we want to solve compound inequalities. And for these first couple, we want to write and graph the inequalities. First, okay, get some definitions. Okay, a compound inequality. Okay, what that is, it's a combination of two inequalities joined by the word and or. Okay, it's a lot like a compound sentence in English. Okay, for instance, if I had this sentence, Bob walked to the store and Bob also bought a sandwich. Okay, two sentences, they could be on their own, but they're joined with the word and. So that's a compound sentence. Compound inequalities are pretty much the same way. So I can put them together with an and or an or. All right, so for the first one, example 1, all real numbers that are greater than -2 and less than 3. All right, so let's use n as my variable. So the numbers, all real numbers that are greater than -2, so I could write n is greater than -2, and I know that they're also less than 3, so I would write n is greater than -2 and n is less than 3. All right, so that's a compound inequality. There's another way I can write this same inequality, okay, and this way there isn't going to be any and. It's going to be sort of a shortcut, okay. So I know -2 is less than n. Okay, that's the same as n is greater than -2. So -2 is less than n, and I also know that n is less than 3. Okay, so this means the same thing, but it's a shortcut. Okay, it also wants me to graph it. Okay, so let's make a graph on our paper. I need to go, let's go 1 less than -2, so -3, -2, -1, 0, 1, 2, 3, 4. We'll put these numbers on our number line. All right, so I know that n is greater than -2, so open circle on -2. All right, and so it's greater, so I'm going to start my line going to the right. Not going to quite finish yet because I need to do the other side. I also know that n is less than 3. Okay, so open dot on 3, it's less than it. So all the numbers between pretty much, yeah, this graph's going to show all the numbers between -2 and 3, and there's my graph. Okay, example 2, all real numbers that are less than 0 or greater than or equal to 2. All right, notice that this one is a compound inequality, but it's an or statement. Okay, or statements aren't going to have two ways to write it like the ands did. There's just going to be one way to do it. Okay, so I know that the real numbers are less than 0, so n is less than 0. Okay, or okay, greater than or equal to 2. So or n is greater than or equal to 2. All right, we cannot put them together like we did with the and statement. Okay, and the reason why, okay, or that means it's either this happens or this happens. Okay, so on the graph, let's sort of look as to why I can't do that. Okay, so if n is less than 0, open dot on n, it's going to the left. And if n is greater than or equal to 2, that's a closed dot on 2, and it's greater. Okay, because it's or, it's either one or the other. Okay, it can't be both. It needs to be one or the other, so I can't put them together. All the solutions are, it's pretty much everything except between 0 and 2. Okay, all right, so for B, I want to solve the compound inequality. All right, so example 1, I have this problem here. And there's two ways to do this. The first way to do it is method 1, so split up the compound inequality. All right, if I were to read this, this is 2 is less than x plus 5, which is less than 9. So I could write that as 2 is less than x plus 5. And okay, also, I know that x plus 5 is less than 9. Okay, so I can break it up into two inequalities and then solve. So take away 5, so it'll be negative 3 is less than x. Okay, and if I take away 5 from both, I have x is less than 4. Okay, so this could be an acceptable answer. Another way to write this would be negative 3 is less than x. Okay, and I know x is less than 4. So if I put it all together, negative 3 is less than x, which is less than 4. Okay, so both of these are acceptable answers. Okay, I might prefer the second one. Okay, but I will accept both. All right. Okay, actually, I just switched it to that, but in method 2, we're going to end up with the second thing here. Okay, so the method 2 is I leave it as it is. So 2 is less than x plus 5, which is less than 9. Okay, so this is sort of a shortcut way to do it. I need to take away 5, okay, and I actually have to take it away from both. So I'm going to take away 5 from both. So that would become negative 3 is less than x. The 5 and negative 5 cancel, so that's gone. And then 9 minus 5 is 4. Okay, so this was the same thing I got once I switched the other one. Okay, I think method 2 is a little simpler, but it's your option as to what you want to do. Okay. All right, so example 2, we'll do this one together, and then you guys will be doing example 3 by yourself. Okay, so I'm going to choose the second method, okay, because I just want to do it a little quicker. Okay, so I need to add 8. Okay, if they were separated, I'd have to add 8 to both the negative 14 and the negative 1. So we're just going to do it all at once. Negative 14 plus 8 is negative 6. So now I have negative 6 is less than x. Okay, which is also less than, let's see, negative 1 plus 8 is 7. All right, so there is my compound inequality. All right, in this case, the variable was positive, so I didn't have to multiply or divide by anything, so the sign stayed the same. Okay, with example 3, okay, we will do 3 together. We're going to solve it. So I need to add 3 to both negative 5 and 2. So negative 5 plus 3 is negative 2. So I got negative 2 is less than or equal to negative x, which is less than or equal to 2 plus 3 is 5. Okay, so remember back a couple days, I need to get x by itself, not negative x. So let's divide both sides by negative 1. Okay, and remember that when I divide by a negative, I need to flip the signs around. Okay, so flip my signs. Okay, negative 2 divided by negative 1 is 2. And let's put the 2 up a little. There we go. So 2 is greater than or equal to negative x divided by negative 1 is x. And 5 divided by negative 1 is negative 5. Okay. So answer is here. Okay, and to make that look a little more proper, let's have the smaller number on the left. Okay, and when I flip it around, I got to flip all the signs. So negative 5 is less than x, which is less than or equal to 2. All right, so both acceptable, but this second one, it would be a little bit better. Okay.